So we're going to kind of fill out this sheet, transformation notes, so it will make your lives easier for taking the quiz and knowing what, doing the review and doing all that fun stuff. All right, who wants to describe, this is kind of in your own words, who wants to describe what a translation is? I like to say a slide, or moving right, left, up, or down. Is it rigid? Does it have isometry? Does it stay the same? I'm going to put isometric up here, or isometry for rigid. Yes, it does. And what is kind of a formula for it? If we have x comma y and we move something, it's either like x plus a number. So we'll call the number hk. So x plus h comma y plus k kind of a thing. Does that make sense? Yeah. Okay, so that's kind of like if we have, so if I say move 2 to the right, 1 down, you would take all your points and go like x plus 2 comma y minus 1. Does that make sense? You're just literally adding or subtracting to them. Now, if it said 2 to the left instead, this would be minus 2, right? If it said up 1, it would be plus. Does that help with translations? Okay. Now, we've got reflecting over the x-axis. Okay? So if we reflect over the x-axis, what's a good way of talking about that when we reflect something? I like to say flipping it. I flip it over. Okay, is it rigid? Does it have isometry? Did it stay the same? Yeah. Okay, my formula for this is I go from x comma y to x negative y. Okay, so a great example of this was like today's warm-up, right? But I'll just do a different one. So if we're at like negative 4 comma 5, it becomes negative 4 comma negative 5, right? Reflected over x-axis. How you feeling about that? Good? Okay. All right. We're going to reflect over the y-axis. This is still flipping it over. Is it still rigid? Okay, so this is, we go from x comma y, we're going to negative x, y. So if I have negative 4 comma 5 again, and I'm going to reflect over y, it becomes 4, 5, right? Okay, this is a harder one, reflecting over y equals x. It's still flipping it over. Is it rigid? Yes. Okay, I have to even look back at my notes for this one. It's a reflection over y equals x. So I go from x comma y, I go to y comma x. Oh, sorry. Is that better? So if, again, I'm going to stick with it, negative 4, 5, and I'm reflecting over y equals x, it's going to go 5, negative 4. So if I'm flipping over y equals negative x, it's a reflection, flipped it over. I might draw like a little drawing right here, because I'm going like this way, reflecting it that way. I'm reflecting it this way. I'm reflecting it this way. I'm reflecting it this way. That visual for me makes a difference. It might not for you, but for me it does. Yes?
So for the reflecting of the y equals x,
Yeah.
just put the x and y?
Yep. So when we reflect over y equals negative x, yes, it's still rigid. Okay. We go from x comma y to negative y, negative x. So again, if we use that same example, negative 4, negative 5, negative 4, 5, and we reflect over y equals negative x, then I'm going to get negative 5, 4. How you feeling about this? Some are good, some are not good. Okay. Rotations. All right, we're going to rotate it 90 degrees, and I'm going to put this on here counterclockwise. All right. So a rotation, what's another way to talk about a rotation? Spinning? Okay. Spin it. Okay. Does it stay rigid? Is it the same shape, just in a different location? Yes. Okay. The formula for 90 degrees clockwise, if I'm going from x comma y, I rotate it, I get negative y comma x. So I'm going to use that negative 4, 5 again. And I'm rotating it 90 degrees counterclockwise. Then I get negative 5, negative 4. Okay? Remember that negative in the y means I change the sign. Okay, 180 degrees. This is for clockwise or counterclockwise, because when you go 180 degrees, it's the same. It's spinning it again. Again, I sometimes like to draw myself a little picture. If I went 90 degrees versus if I went 180, I just feel like that helps me. Yes, it's still rigid. Okay? And if I go 180 degrees, I go from x comma y to negative x, negative y. Oh, I put spit too instead of spin. That should be an N. Spin it, not spit it. Please don't spit in class. Okay, so I went negative 4 comma 5 to a rotation of 180 degrees either direction. Gets me 4, negative 5. I know that's a negative x, but you guys get that you change the sign, right? Okay. Okay, we haven't talked about a rotation of 270 degrees, but we kind of can. This is 270 degrees counterclockwise or 90 degrees clockwise, which means this is 90 degrees counterclockwise or 270 degrees clockwise. Okay? It's still a spinning it. It's just I'm going, that's 90 degrees, that's 180, that's 270. Okay? So we've got 90 degrees, right? Like, I make this 90 degrees, 180 degrees, 270 degrees. It's just like I keep going one more. Nope, that would be 360. Okay, so I go from x comma y to y comma negative x. And that's -4, 5, rotation of 270 degrees counterclockwise or 90 degrees clockwise. And I'm going to get 5, 4. Okay, dilation. Dilation is an enlargement or a reduction. Okay, does it have a symmetry? Does it stay the same? No. Okay, our formula here is we go from x comma y to a times x, a times y. Whatever the dilation is, we're timesing it by both of those. Okay? So if we're taking our original -4, 5, and we're dilating it by, what do we want to do? Do we want to make an enlargement or a reduction? Enlargement. So let's say we're multiplying it by 2. We would go -8, 10. It's twice as big. I times both of them by 2. Questions about any of this?
So for the enlargement, for both of them, you just multiply the x and y.
You multiply the x and the y by it. So if it was in a reduction instead, I would have divided, like let's say it was 1/2. I would have gone -4 times 1/2 is -2. 5 times 1/2 is 2.5. Okay. Okay. So your homework for today is both of these papers. Transformation quiz review, this looks just like your quiz. And then I just gave you more practice. Okay? Transformation practice. Is there any you want to do? Do you want to do a translation together, a reflection, a rotation, a dilation? Okay, who would like to do a translation? Who would like to do a reflection? Rotation? Dilation. Most would like to do a dilation. Okay, let's look on the back of this quiz review where it says dilation of 0.25. First thing I'm going to do is I'm going to have you guys, for all of these, I want you to list the new points because you're going to have to do that on your quiz. Okay, so first I'm going to list my original points. I've got this one over here. This is 3, 1. These are the new ones on the other side. And this is 1, 2, 3, 4, 5, 6, 1, -6, 1. And then this one is -6, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we want a dilation of 0.25. That means what am I going to do to each of those numbers? Yeah. So I am going to go 3 times 0.25 gives me 0.75. 1 times 0.25 is 0.25. -6 times 0.25 is -1.5. 1 times 0.25 is 0.25. -6 times 0.25 is -1.5. And 9 times 0.25 is 2.25. And then I know they're fractions, but I'm going to do the best I can. I'm going to go over not quite to 1. Going to go up 1/4. Yep. Still going to be a little bit hard to see. Then I'm going to go -1.5 up 0.25. Then over -1.5 and up 2.25. So that's my new shape. It is. It's 1/4 as big. Better? Okay, so again, I'm recommending you've got time in class to finish a calculator activity if you have it, and then the rest of the time you should be working on this homework. This reviews are very close to your quiz, so I would do them.